Okay, we've been talking about the medium planets of Uranus and Neptune. As you can probably guess, because they are very massive planets and they have pretty fast spin, they do have pretty strong magnetic fields. And guess what? They're kind of medium strength. They're not nearly as strong as Jupiter and Saturn's magnetic fields, but a lot stronger than, let's say, Earth's. Of course, planets like Mars and Venus don't even have magnetic fields. So they end up being about 100 times roughly stronger than Earth's magnetic field. Both of them have what we call magnetospheres. As a reminder, that's where you have sort of a sea of charged particles around a planet that get trapped, at least temporarily, around that planet. So both of them have magnetospheres. They both probably have aurorae. I know I've seen a picture, we'll see a picture here in a moment, of the northern and southern lights on one of them. I'm sure they both have that as well. Here's where things get a little strange in this area. Both of the planets themselves, as we saw last time, Neptune has kind of a typical regular, rotational tilt, and Uranus is tilted on its side, right? But then when you look at how their magnetic fields are tilted compared to the rotational axis. Now, for example, the Earth has a rotational axis, right, the North Pole, and then we have what's called the North Magnetic Pole. And they're both, north, but they're not exactly in the same place. Our magnetic north actually moves around, in case you don't know that. Sometimes it's closer to Canada, and over the decades it'll go over closer to Russia, but it hangs out, at least the north, in the north, the magnetic pole there hangs out in the Arctic Circle area. But in this case, the magnetic poles and the rotational poles are just very, very different. To make it even stranger, both of them seem to be sort of off-center from the center of the planet. Now, as I've mentioned earlier, when you have mysteries like this, like why is it tilted on its side, and why do they have these strange magnetic fields, when astronomers don't know something, the default answer is something smacked the heck out of them. So in this case, that's kind of what we think, that early in the solar system, something smashed into it, especially the Uranus, because it's, again, that tilt, the rotational tilt on its side. But anyway, this is still a little bit mysterious. Keep in mind, we're really far from the sun. We've only sent one spacecraft ever to visit these planets, so we know the least amount about these outer planets. And so those are some mysteries there that maybe need to be solved. Because of less gravity, less pressure, they don't have the metallic hydrogen layer that Jupiter and Saturn had, which produced that huge dynamo, that huge magnetic field strength there. So that's one reason they have weaker magnetic fields. They don't have that extra layer producing the magnetic field. So on the inside, we think it's simply a gaseous layer, a liquid layer, a liquid ocean of hydrogen, helium, and probably some kind of core of heavier metals and so forth, but not necessarily solid, but maybe so. All right, again, we just don't probably know that much about them other than their overall density. Here's what we mean. So in terms of, you see in pink, let's start here with Uranus here, where, again, it's pointed, it's rolling like a barrel. The rotational axis is actually slightly downward there is north, but then magnetic north, look at that, it's completely off in terms of the angle, and the little bar magnet representing it, you see, is off-center as well. Now, Neptune, you'd think, might be normal because it has kind of a more normal rotational axis, right? You see in pink there, the rotational axis, and then look at this. Its magnetic axis is even more tilted away, right, at an even stranger angle there, and it is also off-center. So just some nice little mysteries out there with these medium outer planets. All right, here's that picture I mentioned of the aurora there that we see on Uranus there in 2011. Okay. Let's talk about their atmospheres briefly. They are both made mostly of, oh, you guessed it, hydrogen and helium. No surprise there. These aren't exact numbers, but somewhere in this neighborhood for hydrogen and helium is going to be 96, 97, 98% of their atmosphere. What's the rest of it? Methane. And it's actually methane, CH4, that gives them their bluish color. Neptune has closer to 3% methane. It has more methane which makes it a deeper blue. And of course, Uranus has less, and it's a lighter blue color. I didn't mention before, I talked about the mythology there of Uranus, and I forgot Neptune. Neptune, of course, is the Roman god of the sea, which works out very nicely because it has that deep, deep blue color there, but it's from the methane, not from oceans. All right, Neptune does give off more heat than it receives. Remember, not that it receives much heat at 30 AUs from the sun, but it does give off more than it receives. Now, there are a couple theories on this. One is that maybe the methane somehow helps insulate it. That was a theory from the old book I used to use. I like this newer theory a lot better just because it's cool. You remember that on Saturn, they believe that it might actually be raining helium. Helium precipitation might add extra heat. Well, there's something else here that could be happening on Neptune. Could be. We don't know. It's just a hypothesis. But there's a thought that it could be raining diamonds. Yes, raining diamonds. That you have the carbon, you have the high pressure. No, these aren't big chunks of diamonds that you could put on a ring. This is more like a dust or something really small. But anyway, kind of an interesting thought there, that it could be raining diamonds on Neptune. Both planets, as we mentioned, at first they didn't know this. In the 80s when they saw Uranus, they didn't think anything was going on. Now we've seen some clouds and storms here and there. Neptune certainly has stripes and bands and some ovals and things like that. The most famous one was the Great Dark Spot that was seen back in 1989 by Voyager. There it is. They got all hyped about it, and of course it was gone a few years later. All right. Moons. Let's talk about those briefly. Uranus, at last count, has 27 moons. Now, I remember when I started teaching back in the 1990s, I remember thinking that Jupiter, Saturn, and Uranus seemed like they had about the same number of moons, if I remember right, all right around 30 or so. The other two planets have jumped up to above 60. Why? Because we've had spacecraft there, and we've had, they're a lot closer. They're easier to see with telescopes and things like that. So I would venture a guess here that there are probably a lot more moons out there that we just haven't discovered yet. But be that as it may, we know there aren't any what we consider large moons. There are 5 medium-sized moons, 2 of them found by William Herschel himself all the way back in 1789, the first year of Washington's presidency, I believe. But anyway, let's see here. Titania and Oberon were the 2 that he discovered in 1789, and then later we found these. Now, those names kind of sound like they might seem somewhat familiar. And then when you start learning some of the other names of moons, Puck and Juliet, yes, these are actually characters from Shakespeare. So for once, we broke with the mythology here, and the Englishman William Herschel named them after characters. I don't think it's just Shakespeare, other English writers, but mainly Shakespeare, the famous ones like Oberon, so forth. Kind of neat. Now, these moons orbit around the equator, just like moons do. But remember, the equator here is tilted. The whole planet's on its side. So when you look at Jupiter through a backyard telescope, you see kind of a line of, like a horizontal line of the moons. But if you were able to see Uranus with a super high-powered telescope, it would look like a bullseye. You would actually see them going around in front of you like this as you looked at it in the telescope. Kind of cool, because it's tilted over like that. These moons are tidally locked, so the same face always towards the planet, nearly circular orbits. That's all just pretty run-of-the-mill garden variety stuff for moons. Moons in the outer solar system tend to be darker. This is because they think there's just kind of a lot of stuff out there that's kind of like soot, carbon compounds that have gotten dark through something called radiation darkening and so forth. Anyway, let's take a look at them. And I'm going to tell you a fun fact here about the moon Miranda in just a moment. So here's a picture of some of these moons. Mostly I just want to show you they do appear to be a little bit darker than the moons further in. Umbriel kind of has a distinctive white spot there, probably from an impact. And then down here, the most interesting one I think is Miranda in the bottom right. You see these really interesting scars. Apparently those would be cliffs if you were there. We're not exactly sure what caused that. Something probably hit it long ago. But they're really high cliffs, number one. I mean, miles high. And number two, you have super low gravity. So apparently if you were going rappelling anywhere on the solar system, this would be the place to go. And if you did happen to fall off, I mean, you're going to have a lot of time before you die. Now, falling that far, you're not going to accelerate very fast in such low gravity. But if you're falling that far, you eventually will die. But you're going to have a lot of time to, send out some tweets or whatever you're going to do. You've got plenty of time to make some Facebook posts, go Facebook Live, whatever, because it's going to take, we'll have to calculate it in class, but it seems like it's like you fall and you're falling for like, half an hour or something like that. So kind of fun. All right. There you see Portia and Puck and some of these other smaller moons. Neptune now has 14 moons that we know of. Its moons tend to be less regular, less garden variety, and especially the one that's by far the most interesting is the last large moon of the solar system, Triton. Triton, discovered just not too long, a few months after Neptune itself was discovered, and Triton does something that no other large moon does. It orbits with a retrograde orbit. This has some really interesting consequences, by the way. So it's the last of the large moons. It is one of the coldest, if not the coldest place in the solar system. In terms of places you could go visit and stand, wow, this is close to negative 400 degrees Fahrenheit. Crazy, crazy cold, and yet there's action even there. You have geysers, not ice geysers, not like Enceladus, not like Europa, but geysers of liquid nitrogen. That's pretty awesome. Again, that's on Triton. Very interesting moon for being that far from the sun to have that kind of action. And then what about this retrograde business? Well, first of all, that tells us, number one, that it didn't form with Neptune. It's definitely a captured object. In this case, I wouldn't call it a captured asteroid per se. It might be from what we call the Kuiper Belt. We haven't gotten to that just yet, but a Kuiper Belt object, a KBO, might have been coming along and got captured in Neptune's gravity. I think that's the most likely scenario. Because it's going backwards to the direction of spin, that has some interesting consequences. Remember how our moon, for example, drifts farther away from the Earth over time. That's why the moon's getting smaller. That's why we eventually won't have total eclipses. In this case, guess what? When it has a retrograde orbit, the opposite is true. It's getting ever so slightly closer to Neptune year after year, which means eventually it's going to cross what we call the Roche limit and probably break up. And when it does, Neptune is going to be the ringed planet. And I think this occurs at a time when Saturn's rings may not be there anymore. So Neptune may have this huge, amazing ring, maybe larger than Saturn's rings in terms of total material. Really cool stuff. Look at Triton. Look at Triton. Interesting place. At the very bottom, you see these sort of smokestacks in black there. Those are the liquid nitrogen geysers. And then this area is one of my favorite names in the solar system. It's literally called the Cantaloupe region of Triton. Yes, perfect name. Look at it, the Cantaloupe region. Okay, and last and least, I must say, I don't really care much about this. I think the only cool thing about the rings, both of these planets have rings. The only cool thing is how they were discovered, a stellar occultation. In other words, the planet Uranus was passing in front of a star from the perspective of the Earth, and the light kind of flickered on both sides of the planet, and we knew then that it had some very, very small icy rings around it. Neptune's rings weren't discovered until we were right up on the planet in 1989. So 10 years later, that's when we confirmed that all four of the so-called gas giants had rings. So we think rings are very common, based on we're 4 for 4 for our large planets. And it seems at this point pretty obvious to me that they come from the collision of moons, the destruction of moons. They're definitely tied in with the moons. And we'll take a look here at some of the rings here of Uranus and a couple shepherd moons there and the rings of Neptune.